talk about position versus time. Position versus time is just a type of graph that we're going to be using in physics. When we have time, we always know that time is going to go on the x-axis. So I'm going to put time down here. Now therefore that leaves position as our y value. When I'm graphing, there's certain things that I'm looking for. I'm looking at a constant velocity, am I looking for something accelerated, or something that's just at a standstill. When I have a position time graph, here's what's going on, here's what I'm looking for. If I have a slope, that's telling me that I'm moving at a constant velocity. So if I have seconds down here, if I actually put some times down here, and in 1 second, I have moved a certain amount. Let's say in this case is 1. After 2 seconds, I have 2, so on and so forth. So if I have a straight slope, that's going to tell me that I have a constant velocity. Now, if I've got a curve, that's telling me that I'm accelerating. Okay, so at 1, I'm here. 2, I've got a little bit further. 3, pushing it, and 4, all the way up here. Okay, so if I look at that, that's going to show me that, hey, I've got an acceleration curve. And the last thing we're going to look at with the position time graph, straight line. Okay, if I have a flat slope, there's nothing there. All that tells me is that at 1 second, or 0 seconds, I'm at 3. At 1 second, I'm at 3. 2 seconds, I'm at 3. That just tells me I'm stopped. There's nothing going on. That's probably the easiest thing to read with the position time graph, is I'm just flatlined. For whatever reason, velocity time graphs usually kind of kick us in the tail. We look at them and we don't necessarily understand because we're so used to looking at a position time graph. So let's go over velocity time graph and how they can be beneficial for us. If I have a velocity time graph, my velocity is going to be my y value, and as always, time is my x. Now, if I have a constant velocity here, instead of having that slope that's going straight up, it's going to be similar to what looks like a stop position on a position time graph. Because if this was my position, or my velocity, I'm at 1, 2, 3, what this is saying is that I'm constantly going 3 meters per second. So I've got that constant velocity there. Now, if I have an acceleration, my acceleration is going to be, not that. My acceleration is going to be that straight slope line. Okay, so at 1 second, let's say I'm going 1 meter per second. At 2 seconds, I'm going 1.5 meters per second. At 3 seconds, I'm going 2 1/4, so on and so forth. So if my velocity is changing, my velocity is increasing, that's telling me I'm accelerating. All right, and the last one we want to look at here is going to be this guy. Okay, and what this would tell us is we don't have a constant acceleration, but our acceleration is changing. We're increasing our acceleration throughout, which does happen. We won't deal with it a lot in this class, but this would just be acceleration is changing. Okay, the nice thing about a velocity time graph is that we can read what's underneath here, and it's going to give us some information. So let's take a look to see what our units are. So velocity is meters per second, and we have time equal to a second. If I find the area underneath the line, what that's going to be is going to be meters per second times second. So if I take a meter per second times a second, which is that right there, our seconds cancel out, and we are left with meters. So the area underneath the line, our velocity line, is going to give us our displacement, which in this case, I have a nice constant velocity. I'm reading it straight across. And let's say mod, I want to know what my displacement is after 4 seconds. So I draw that line down. I have 3 meters per second, 4 seconds. My total displacement is going to be 3 times 4, which is going to be 12 meters. Okay, now that works with any geometric shape that we have. So sometimes we'll be dealing with rectangles, sometimes we'll have triangles. Just remember that triangle area is 1/2 base times height, and you ought to be good to go. All right, that's it for today. Make sure that you are doing what you're supposed to be doing, getting your web assign done. We will be starting with kinematics here shortly.